Hi everyone, I'm Sandhya, Department of Mathematics. Today we are going to discuss about the properties of Fourier transform. In this properties of Fourier transform, we are going to see about the linear property for sine and cosine transform, and change scale property, and shifting property, and modulation property. Okay, so first we are going to see about the linear property in this Fourier transform. So f of small a f of x plus b into small g of x equal to a into capital F of x plus b into small g of x, where a and b are real numbers. Here we are going to see a prove in this linear property is we take the left hand side, then we have to prove the right hand side. So f of a f of x plus b g of x equal to 1 by root 2 pi minus infinity to infinity a into f of x plus b into g of x e power I s x into dx. Next we want to split in the integral. So minus infinity to infinity f of x e power I s x into dx plus g of x e power I s x into dx. Here a is a constant, so our capital F of small f of x is nothing but 1 divided by root 2 pi minus infinity to infinity f of x e power I s x into dx. So this is equal to a into capital f of x plus b into capital F of g of x. Okay. Similarly, we have to prove that Fourier sine and cosine transform. So in this sine transformers, we put in the suffixes yes. If it is a cosine transform, we put yes. So it is a half range. So we have to use the limit as 0 to infinity. So here also see the formula capital F of yes, a f of x plus b g of x equal to root 2 by pi 0 to infinity a into f of x plus b into g of x sin sx into dx. So here we want to split the real and imaginary part. So a into root 2 by pi f of x sin sx into dx plus b into root 2 pi g of x sin sx into dgx. So a is a capital F of s into f of x plus b into capital Fs g of s of x. So this is the linear property sine transform. Similarly, we want to prove it is a linear property of cosine transform. Okay, next we are going to see about the change scale property for any non-zero real a. Capital F of small f of ax equal to 1 by a, capital F of s by a. Here we want to prove take the left hand side, then we have to prove the right hand side. So capital F of ax equal to 1 divided by root 2 by pi minus infinity to infinity f of x e power I s x into dx. So capital F of ax equal to 1 by root 2 pi minus infinity to infinity. Here we want to change x in terms of ax, so that is e power I s x into dx. Then we take t equal to ax, then we have to differentiate dt by dx equal to a, then dt equal to dt by a. So here we want to substitute ax is t. So here we want to change the t also. So instead of x we replace t by a and dx is dt by a. So this is the 1 by root 2 by pi minus that is minus infinity to infinity f of t e power I s t by a into dt by a. Here some a is constant, so take it outside. 1 by a into 1 by root 2 by pi minus infinity to infinity f of t e power I s t by a into dt. So this is our f of s. So in this power e power I s x instead of t by a. So here we want to use f of s by a. Okay, so this is the change scale property. Next we want to use the shifting property. So in this shifting property, capital F of small f of x minus a e power I s x into dx e power I a x into f of x equal to f of s plus a. So f of x equal to 1 by root 2 by minus infinity to infinity f of x e power I s x into dx. Here also we replace x instead of x minus a. Then we want to substitute t equal to x minus a. Then we have to differentiate. So dt equal to dx, and then the range is minus infinity to infinity. So after that we replacing t and dt value. So here the values is e power I a x into f of a capital F of s. Similarly f of e power I ax f of x equal to f of s plus a. Here also we replace that is 1 by root 2 pi 0 to infinity e power I ax f of x e power I s x. Here the exponential is same, so adding the power, so this is the f of s plus a. Okay, so similarly we want to prove the modulation properties. Fourier transform f of s is a Fourier transform of f of x, then capital f of x cos s x equal to 1 by 2 f of capital F of s plus a plus capital F of s minus a. So f of x is nothing but 1 by root 2 pi minus infinity to infinity f of x e power isx into dx. Okay, so here we replace cos x is e power iax plus e power minus iax by 2. Okay, so here we take 1 by 2 as outside, so e power I instead of a we replace s plus a, then we have to split the integral. So this is the formula of 1 by 2 capital F of s plus a plus capital S f of s minus a. So similarly we want to prove the Fourier sine transform and the Fourier cosine transform. Okay, so similarly we want to prove this property also. This is very very important property. Capital F of x power n f of x equal to minus 1 power n dn ds into f of capital S. So here you know the capital F of S problem, then we have to differentiating with respect to x on both sides. So d power n ds power n f of s equal to 1 by root 2 pi d power n ds power n minus infinity infinity f of x e power isx into dx. Okay, next here we replace f of x is nothing but e dou power n divided by dou s power n f of x e power isx into dx. Here the f of x value is ix. So f of x ix whole power n into e power isx into dx. So here I is a constant, so take it outside. So finally I power n capital F of x power n into f of x. So comparing the left hand side and right hand side, the value is 1 divided by I power n d power n ds power n f of s. In this I power n is we take it in the numerator, so minus I power n d power n divided by ds power n f of s. Okay, so thank you.